Well, thank you for the introduction. A short, very short overview of who I am. I am, working a long time in process industry. I actually started in 1977. I forgot that in this overview because I started in 1980 with Honeywell. Stayed there for 43 years till 2023, and then retired and started the Cyber Physical Risk Academy. I'm running the Cyber Physical Risk Academy, like was said, but I'm also cleaning it. I'm doing everything. It's a one-person academy, so don't think it's a very big company. And I'm focusing on education, primarily sharing my knowledge. I've done all kind of in-company trainings, guest lectures at universities, all kind of stuff. I'm not in there for business. I'm just in there for sharing knowledge. Let me start my presentation. This is kind of the overview. I will first start with, and I'm not happy with the way we're looking at OT security at this moment, and we should consider looking at it differently. And that I do by showing a little bit about the difference between system-centric, which I think is the present way we look at OT security, to move it in the direction of control-centric. I will discuss a little bit how that will impact organizational ownership of risk. I come with a very, very brief case example to illustrate things. And then I end with a slide coming up with the big picture, what to do. Well, like I mentioned, I believe that when we started OT security, and I think I was in there from the very, very, very first days, because working for Honeywell introduced open technology in the early 90s. First Unix, and in the end 90s Windows, and with the introduction of Windows, almost immediately security became a topic to look at, and that became my more or less my focus from early this century on. And I think what we did early was looking very much on how IT secured systems, and we tried to copy that. We tweaked it a little bit. We made our own changes. When ISA 99 work group was starting in the early of the century, 2002, 2003, working on what later became the 62443, when they worked together with IEC. That standard also was very much the way you would say IT would have done it, but changed for the new requirements that OT technology needed. But still, it was what we call system-centric. I'll explain a little bit later what system-centric means, but this presentation is about trying to escape that view and extend the view a little bit wider than that, because there are more there's more security necessary, there are more gaps in the security, more risks that rise outside this system environment. So what I started to do is I kind of created for myself kind of a maturity model that we started with ad hoc security reasoning, where we're just looking at the basics, not very much structure in that. And then we started to structure it. ISA played a very important role in that. ISA 99, the IEC 62443 standard that was published, I think the first real official publication was 2012, if I remember well. So that's already a long time ago. I started working in the work groups since 2007, 2009, in that period somewhere. I started contributing to various, basically first to the 3.3, the ones that defines the requirements. So that's the system-centric thinking. I think what we need is a step upward to also look at what we are actually securing, which is the control process. So that is what I call the control-centric thinking. It's not a replacement of, it's kind of extending the look at the system. And finally, what you would need to do is looking at it from a cyber physical point of view, because you want to have priorities set. You want to know why you secure something and in what priorities there are. And you need sometimes to check if you meet certain risk criteria set by regulations. So this is kind of a growing awareness. Don't see it as a replacement of. It is always there. We always need system-centric thinking. I think we need control-centric thinking, and most security today is kind of stuck at system-centric thinking. That's what I try to show in this slide, where I have the who, the ad hoc, the how, the system-centric part, and then we have to go to the actual process, the what and the why in the control-centric. And there is a gap between those two. And how to fill that gap? Well, that is basically, I identified 4 areas where I think improvements can be made. We are very much thinking in compliance-based security, like we need to follow ISA 99 or IEC 62443, the longer word for that. And well, we check all the marks, then we are happy with security. Well, I think it's much better in a critical environment to be risk-based. I didn't say that in my intro, but my world started out and worked very much in the process industry. So in petrochemical industry, refineries, offshore industry, pipelines, but generally critical environments where when things go wrong, you can actually die from accidents, and they happily never happened from a security point of view, but theoretically that's possible. And so we need to properly secure it to prevent that. Because in a control environment, you always also have to think what happens if it fails. So what happens if security fails? And can we still limit the damage in that situation? And that's what control-centric kept trying to close. We have, in a system-centric environment, we have very much an asset perspective. We try to protect the infrastructure, we try to protect the servers, the desktops, the controllers very much, and hope that when we have done that, we also have protected the process. But above an asset, there is a function, and a function connects assets and groups assets. Some functions have multiple servers and multiple stations, and there are all kinds of trust relations between these nodes that just cross borders. So you can have a nice segmented network that tries to protect very critical nodes from being attacked, but sometimes through trust relationships, these nodes can be directly influenced from a much more exposed environment. So that's asset function perspective, system-centric, control-centric. I'll come to that in a few slides in much more detail. And then I like to see a much more integrated security approach where we see now we have OT security organization, we have process safety organization. I prefer an environment where that's much closer together, and I will explain why for each of these elements. If I look at the compliance-based security, let's say IEC 62443 as one example, but there are of course other standards in use. Then you focus a lot on policies. We translate typically security requirements that you need to fill, specific procedures. You do your audits, you have a control checklist on what you implement, yes or no. And there's a lot of documentation focus in the sense that you want to document what you have done. In a risk-based security, you're much more looking at where are my biggest problems, and you try to order that, and you try to detect from the real system what the issues are, and you're trying to analyze also from a process side. The whole idea of having more control specific security comes from when you start doing cyber physical risk analysis. You need this process. You need to know about the consequences. You need to know how these consequences are becoming reality under certain circumstances. So risk-based security offers a lot more additional view, a lot more additional detail and ways to manage security than just compliance-based. About this asset perspective and functions perspective, I already mentioned it. If you have an asset perspective, you have your nodes, your assets, your servers, your desktops, your PLCs, controllers, routers, whatever, your boxes in the network, and you try to protect it. You protect it by segmentation, you protect it with hardening, by, say, closing all kind of services to minimize your attack surface. Basically, asset perspective does two things. It tries to reduce the attack surface, and it tries to reduce the attack distance. Attack distance you typically do with segmentation by placing your most critical nodes in segments that are further away from the boundary, from the outside boundary, the external boundary. And attack surface you do typically on the nodes itself and a little bit on the filtering of the various segment security zones. And the whole asset perspective is security zones and conduits, like in the IEC 60443. In a function perspective, then you look much more to, okay, we have something like alarm management, we have something like laboratory information management, instrument asset management, we have maybe basic process control systems, safety systems. But if you have those type of systems, if you buy those type of systems, typically there are multiple components. You have multiple servers sometimes, you have servers and desktops, you have servers, desktops, and controllers together. And there are lots of relationships between those that you have very little control over. There are lots of trust relations implemented. And trust relations kind of shift the risk to whoever owns that trust. And sometimes there are situations, and I'll show you an example later, where you even can have a trust relation in the outside external world at level 4, or even sometimes in cloud environments. So looking security from a function perspective gives you a different view than looking at it from an asset perspective. If you talk about system-centric, well, I already mentioned it, who, how, user roles, so access, assets architecture, all that type of stuff is the focus. If you, on the other hand, look at control-centric, you look much more to what the system is actually doing, more to the application side. What is controlled, how it's controlled. So you actually not only look at the software side of that, but also at the process equipment side, the pumps, the compressors, the absorbers, or whatever you have in your system as a physical function. So control-centric looks at security from that area. What system-centric view governs is, of course, all these asset inventory, the network segmentation, the protocol inspection, firewalling, use control, all that type of stuff. Basically all the type of stuff that IEC 62443 addresses for you. What it misses is a very important parameter, what I call control proximity. Control proximity is the parameter that shows how close basically the threat actor is to influencing the process. Yeah, so if I have a function and I put that function in demilitarized zone, that from where I immediately can influence the process, then a very high control proximity in that function in the demilitarized zone. And sometimes we have situations, and I'll come to that example later, where we actually put nodes with a very high control proximity outside our process control parameters. Well, you have functional authority. There's another element. Functional authority is very complex in process control systems because it arranges not only getting access to a system, but also what you can do at that particular point as a user. Operators have different authorities. Not every operator can operate every process unit. Not every operator can make modifications to the system, to alarm limits, to enable, disable alarms, and things like that. There's a whole layer of additional authorities that are not really covered by the traditional domain controller type of authorities arranged at the system-centric environment. Operational context, of course, in a control, function to consequence mapping. So what happens, which functions have particular possibilities to create particular consequences. And there are lots of indirect influences. This brings kind of a new, I didn't see that much mentioned in, there are some literature discussing this type of thing, but that your exposure, basically cybersecurity, we try to minimize the exposure to the attacker. The attacker needs sort of an opportunity to attack, and that opportunity translates in the exposure of our vulnerabilities in the system. Every system has vulnerabilities. Even if you have patched it, there will still be vulnerabilities. So you protect your system by minimizing your exposure. If the attacker has no exposure to vulnerabilities, then he has no opportunity. We do that, like I mentioned, by attack surface. Well, I guess all of you know how to do that. We minimize all kind of services. We disable unused services. We lock ports in the communication. Attack distance, already mentioned it. We talk about segmentation. We put critical nodes in segments that are kind of surrounded by other segments. We put our controllers in level 1 and not in level 3 or in the demilitarized zone. So that kind of creates attack distance. But attack distance is totally overruled by the third one, control proximity. If I have a function in the demilitarized zone, or even in level 4, that immediately can influence controller settings, then my control proximity is very high there, and my attack distance can be maximum, but control proximity will win from it. So in a control-centric environment, exposure is basically 3 dimensions: attack surface, attack distance, and control proximity. Let's look at the organization for a moment. I think when we divide the organization such that we have a separate OT security ownership of risk, and we have a process safety ownership of risk. I talk here about ownership of risk, not necessarily how things are managed, but who owns risk? When you have that type of situation, you can have conflict in control. OT security can make other priorities than process safety. And I could show you some examples of that. Time doesn't allow that, but you basically have two drivers in one car. And my worry is that sooner or later will go wrong. And from there, I kind of promote that we should find a way to organize it so that we have only one owner of cyber physical risk. And that owner, in my perception, should be process safety, because they basically own the consequence. Process safety in a plant has always focused on consequence and how to protect the plant against these consequences. And they used to do that based on random errors of failing equipment. So I think we should extend that. And that's why I've this slide. Basically, risk starts at the process hazard, at the consequence. And then there are a number of functions that can deviate that cause this hazard. And then we have the actual technical cause. It could be wear and degradation, which is the typical environment of process safety. It could be human error. Process safety also looks at that. Misconfiguration is already a little bit in between, but process safety typically also focuses on that. But what we see today is that when it becomes malicious, then suddenly the cause will be handled by OT security and the risk by OT security. Well, I think it's still the same consequence. The cost is different, but it's the same consequence, needs to meet the same risk criteria, and should be managed well, kind of a unified way. So what does that mean? Well, first of all, I think this is what we should have. We should have kind of an embedded situation where OT security becomes part of the process safety, part of the process safety thinking. OT security thinks about lots of orchestrated attacks. The process safety generally ignores it. We should try to avoid that. And with an orchestrated attack, I mean that process safety looks typically if one particular valve will fail closed or open or a pump will stop or whatever. What are the consequences if that happens? And they will safeguard against that. But they typically will not look at situations where cause A is followed by cause B, is followed by cause C, or in some other more malicious sequence, because they consider that it's very unlikely that at a particular point, three elements or two elements even would fail simultaneously or in a specific sequence. So they typically ignore that. And but still, it's important and creates often new consequences that are forgotten about in process safety analysis. So we need to join that. Well, it misses how control loss leads consequence. No integration around the chain. Well, I can, for time's sake, go over this very quickly. So what I want is an organizational shift for, like I mentioned in the previous slides, but I also want to see an expanded scope, expanded OT security scope, where OT security also looks at the control side. That requires this to bridge this gap. Okay, let's quickly go to an example in the last 4 minutes. Which happens very often is that you have laboratory information management systems in plants. They sample, typically manual often, sample some of the products created, some of the intermediate products created, looking at quality, but sometimes also looking at how far a particular reaction has taken place. And in the old days, the lab would create a nice report and would give that to the operator with kind of a suggestion on what to do. What I've seen in today's systems, that more often the lab systems are directly connected to the APC. So the results of the lab directly feed into the advanced process control environment, and the advanced process control environment will automatically start modifying set points and well, sometimes even direct digital control outputs, depending a little bit on the type of control. So the danger here is that when you have when you manipulate the information already at level 4, that you can create stuff that you don't want to happen at in the field and with the process, even dangerous process like suggested here, when you have a monomer concentration data manipulation. So that is kind of the danger that happens, and so the control proximity of these LIMS is very high, basically. Even the control proximity of the APC is already high, but we have moved it all the way to level 4. So we have segmentation, but because of all these risk, all these trust relationships, actually these parameters are ineffective, because level 4 is trusted by level 3 in this case, and there are only very limited checks often done on these values. There are, of course, some checks if it's within certain bounds, but even there are ways to manipulate that, and most processes today run really at the end of their safety margins, because they have to produce much. There's a lot of high production. There's not that much space left for error in some cases. So that's why control proximity is important. Like I mentioned, you have exposure. In the system-centric environment, it's attack distance, attack surface. In the control centric environment, you have this third axis control proximity. And control proximity always rules what you look at. So if control proximity is high, then attack surface, that combination is important, but if the attack distance can also be fully overridden by a node with control proximity. Like in the case of the LIMS, the Laboratory Information Management System, if I start manipulating values there, that could end up in wrong set points all the way at the controller level. And things are very complex in nowadays process control. So not always clear for an operator if a value is right or wrong. And if he's not, in the old days, he was confronted with that on paper and he immediately saw, hey, this is a funny value. I've never seen that before. Nowadays, things happen a lot more under the hood, outside visibility. So my last slide, in my last seconds, some strategic directions. I think we should more integrate cyber and process risks, because it's the same risk criteria. So try to break down the silos between OT security, process safety, and operations. And who owns it? I don't really care, but it should be one single owner. It should not be a divided ownership. Shift from system to function focus. I think we should have to look at functions, because functions have all these trust relations, have all kinds of dependencies, which create risk. And if we only look at assets level in infrastructures, we forget a lot of vulnerability, a lot of opportunity for the threat actor. So I would suggest that we move cybersecurity from system-centric to control-centric. We have to embed security also in the process thinking, so it's a two-way initiative. Process safety should also start thinking about a little bit about those elements that they considered now as very much unlikely to happen, that they can still happen if it's done maliciously. We should extend our monitoring capabilities to better spot if certain values in the system kind of impact our operating window in a negative way. And assign functional accountability so that at every level we know who is able or allowed to make specific changes that can impact consequences. And there are gaps in that. Okay, that is my presentation. I think I've overrun it by 1 minute.
Thank you very much, Sinclair. That was quite amazing. And I have a lot of questions, but no time, unfortunately. So thank you very much. Really appreciate it. And of course, if anybody wants to contact you, they can chat with you, or your details were presented earlier. And of course, the slides and the recording will be shared